Welcome back. In the first episode, we talked about what is design in general, and now we're going to talk a bit more about engineering and the design process. This is one way to look at the design process. You can pause and take a look at the different steps. And this is the design thinking process that we follow at Punahou School. And you might think at first that this process of learning how to collaboratively solve complex problems may not directly relate to a robotics competition, but if we take a closer look, it does. First step, to empathize. Usually, when we're designing things, it's to fulfill a need and it's to help somebody out. But in our case, we are trying to understand the game. And that's why so much time and attention is dedicated towards understanding the game and making sure that you understand what the rules are and what you are allowed to do and what you aren't. The next step, you'll think about defining your problem. In this case, it's the robotics season. So, individually and as a group, you want to prioritize what you want to learn and how much of a challenge you want throughout the season. And then, throughout the rest, at all different levels, which we'll talk about in a moment, you'll go through this ideation process, coming up with lots of ideas, and then making some of them, selecting, prioritizing which ones to do along the way, building it, testing it, and then repeating based on whatever feedback that you get. If you really want to distill this design process down, ideate, select, test. You're doing this over and over and over again. Often when we hear of brainstorming, we just think that you're in a room with a group of people and just trying to come up with the next best idea. Um, I would encourage you to first take some time on your own to come up with ideas, and then you can present them to others and you can build upon them. When you first start out with coming up with ideas, there are various struggles. So the topic could be too broad. This could be the design challenge that you're faced with, or it could be some sort of societal problem like solving world hunger or curing cancer. There's so many different ways to go about it. So, one way to try to address that issue is to divide and conquer, to build out a mind map. You want to be able to focus on the different areas. The next struggle might be feeling like you don't have enough expertise. So then you want to do more research, ask for help. In the case of a robotics competition, you have a lot of help around you. First, you definitely want to try to look at the resources yourself. But then, if you feel stuck, something doesn't make sense, there's so many, both older students and adult mentors around. This last one is something that I think as people get older, it actually becomes more of an issue. When we take a look at younger children, they do not have any inhibitions. They are willing to just put whatever idea out there. But as we grow older, we always have this self censoring voice in our head to say that's a lame idea. And in the ideation phase, we want to let go of that. Let go of that and judge later. If you really are interested in improving your ideation skills, practicing improvisational comedy can be a huge benefit. So, to combat some of those struggles, first you want to defer judgment, meaning you realize you'll judge later, but right now you're putting it all out there, throwing up all those ideas. Once you work in a group, you want to build on others. You might think, hey, it's a lame idea, I'm not going to share it, but you saying it may allow somebody else to build on it, or it might just remind somebody of some other way to develop the ideas, or just might not be obvious. You might think it's obvious, but it's not obvious to others. You can change and challenge assumptions, constraints, and viewpoints. In the case of a robotics competition, you eventually have to abide by the rules, but maybe there's different ways to understand and interpret. And in the case of robotics competition, they may clarify it and prevent you from being able to do something, but don't necessarily just do what everybody else is doing. And this is one of the reasons why you are welcome to take a look online to see all the different elite teams out there sharing their things, but don't get fixated on those paths. Don't Those aren't the only ways. And remember that you can always reform and mold the wild ideas into something that is more feasible. And in the ideation phase, just always look for the next answer. Don't settle at the beginning. You want to aim for quantity, and quantity will eventually lead to quality. Okay, this slide is very important. This is actually adopted from a process that is taught at MIT in mechanical engineering. So it's modified, but it is talking about when you come up with ideas, there's a certain hierarchy. And I'm just going to talk through it and it'll make more sense. So, first of all, is what is the strategy? So, if you think about different sorts of games and sports, there's an end game, there's some sort of point total, but there's different ways to go about scoring. And if you have sports teams that are facing one another, they may adapt their strategy depending on who their opponents are. Then you have a concept. How do you actually achieve the strategy? So, in the sports context, maybe it's a certain type of lineup. Maybe you're going for particular players that have the sort of strength. In the case of robotics competition, it would be some sort of concept. Is it a sort of claw concept or a forklift or an elevator? And then lastly, you have the design. The design are the actual mechanical pieces. You can say that the design can have many modules, and then the module can have many components. Um, the vocabulary is very important because otherwise, if you don't have names for these things, then people will just fall back on saying the thing or the stuff or whatever it is. This bottom part is more of just a reality check. Um, you want to eventually, you want to make sure that you are fitting within the limits of the competition. You want to show your work. All right, you want to say, hey, I saw this on some team's website, or I saw this machine or vehicle in real life, and that helps people see what or how you were inspired by. And this last piece, all right, is saying that any design, you're doing it because there's some sort of reward, but there are inherently risks. All right, there are opportunity costs. You do one thing, that means you can't do another thing well. So you're just acknowledging the risks and saying, are there ways that you can counter those risks? And if not, that's okay. Merely acknowledging them is huge. So, in summary, the strategy, all right, what are the ways that you want to score? And actually, more broadly, what are your goals for this robotic season? So, think of that as the why. Your concepts are going to be what does the robot do? So, you think about at game day, on competition day, you're going to walk around and describe your robot. What is it that the robot can do? What of all the ways of scoring can your robot do? And then, actually, your designs, that's the how. What is the robot made of? What are the different components? How did you put these components together? How does the robot do the what that you have set out to do? And then the what of the robot goes back to the why. What sort of challenge do you want? And what are the different ways of scoring? You can also think of the design process as a alternating of divergent thought, thinking wide, and also convergent thought. Divergent can also be thought of flaring out. Convergent can be thought of focusing. So you do this back and forth at all the levels of strategies, concepts, and designs. It's much better to have an awesome plan and poor execution versus a decent plan and an excellent execution. All right, you want at the end of the day to have a good, reliable robot. Towards the beginning, you can come up with crazy ideas, but at some point, you need to be a bit more realistic, work with other people, work within your team, and get advice so that you can get a good, reliable robot. These are other places that you can learn more about selection and drawing, and maybe we can save that for another episode.